I'm Aimee Curtright. I'm a physical scientist at RAND. The lead author of this work was Aviva Litovitz. She is a PhD student in our Pardee RAND graduate school. There is a range of potential impacts associated with the extraction of shale gas, but one broad category is air pollution. And we wanted to do a case study of the potential magnitude of this impact in Pennsylvania, where Marcellus Shale extraction activity has increased dramatically in the last few years. In this letter, we provide a first-order estimate of the direct conventional air pollutant emissions that are associated with the extraction of unconventional shale gas in Pennsylvania. We also estimate the monetary value of the associated regional, environmental, and health damages. The analysis does not consider the greenhouse gas implications of using shale gas, and we don't estimate the net implications of substitution effects, such as replacing coal with natural gas to produce electricity. Our results indicate that in 2011, the total monetary damages from conventional air pollution emissions from Pennsylvania-based shale gas extraction activities ranged from about $7.2 to $32 million. For comparison, the largest coal-fired power plant in the state was responsible for about $75 million in damages in 2008. So the total monetary value of the damages is actually fairly small relative to the many other emission sources in Pennsylvania. On the other hand, the damages are not going to be constant over time, and they're not evenly geographically distributed. And there are some important implications related to when and where these emissions damages occur. So, for example, in the counties where activities are concentrated, the cumulative NOx emissions from shale gas activities were on the order of 20 to 40 times higher than what would be allowable for a single minor source. So the activity is equivalent to adding a major source of NOx emissions in these counties, even though the individual facilities are being regulated as unrelated discrete minor sources. With respect to when emissions happen, 2/3 or more of total emissions are related to the ongoing activities of gas production and compression. And compressor station activities alone represent 60 to 75% of all damages. And these emission sources are going to be around for many years beyond the more visible development phase, after the truck traffic has subsided and the well drilling and fracturing have been completed. It's interesting to note that the majority of these emissions are unrelated to the fact that this is an unconventional resource. So this is not a shale gas problem, but it's an issue that you would face really with any large-scale industrial activity. These results have a number of important implications. With respect to research, our estimates in this letter relied on some preliminary and incomplete data. So local and regional monitoring and additional data collection are going to be important for understanding the potential problem in regions where there's intense activity. Consideration of site-specific variability is really not possible without this better data. One policy implication is that regulatory agencies in the shale gas industry, when they're developing their regulations and their best practices, need to consider the air emissions from both the development activities as well as these long-term activities. And the cumulative multi-source impact is also really important to consider when we're developing policies. Better understanding of both the magnitude of emissions as well as the appropriate regulation for these emissions is important, because under current standard industry practices, these extraction-related emissions are virtually guaranteed, and they're going to be part of the cost of doing business.